Hey, hey, hey! So I paused the video a minute ago, switched the entire piece of paper that you were going to be working on, and now we're going to go ahead and get started on a couple of examples. These examples are going to try to connect the dots even further why we're talking about these equations at the same time as we're talking about graphing straight lines and doing all the things that we've been doing. So right now, after since Mr. Shelton has already given you the paper, let's go ahead and get started with the first example. Please, 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 please take note of what it says at the top of the page. It says, please don't work too far ahead. The video will help fill these in. I'm talking about this video right now, and I'm talking to at least one of you in every single class. You know who you are, Aiden. Or I guess I could talk about Ian. And I could talk about Emily, or I could talk about Caroline. You know who you are, and I'm telling you to slow down for a minute, please, because I want to try to connect all these dots again. First thing I want you to do, the top two graphs are both in point slope form. Did not realize that I gave you the same slope on both of them until now, but I do want you to go ahead and graph and T-chart both of those. I know most of you don't feel like you need the T-charts anymore, but I want to try to illustrate the purpose of this whole entire lesson using the T-chart and then talk about equations as a way to support that. I'm going to make my T-chart stay inside of those boxes because below the graph itself, I'm going to use that space to solve and set up some equations. If you remember the rules on how to start your graph and create your T-chart, you should already be done with both of them. First thing that you're supposed to do is figure out what the X is. Parents in the crowd, the X comes from the inside of the parentheses. What would cancel out positive 4? It would be a negative 4. The Y value comes directly from the outside of the equation. It's the negative 3 hanging out at the back. So if we use that same logic on the next graph, that means we should be starting at a point of 1, 3. The slope says the change in y over the change in x is 2 over 1. So I'm going to count by 2's on the y side. I'm going to count by 1's on the x side. This gives me a relationship that says start at negative 4, negative 3, and then use the slope to create your next couple of points. Here's the line that I'm graphing. Boom. So on the other graph, again, it said to start off at 1, 3, but then to use the slope to help me continue filling in the chart itself. I go from 1, 3 to 2, 5 and to 3, 7. That's going to give me a line once again that has a slope. I started at a particular place, and that could go on forever in each direction. So connect it back to first chapter. This is the domain and range. The domain and the range says that it could be anything. Those arrows say I can go on forever. I don't have enough boxes to show forever. You'll never have enough boxes to get all the way to infinity because you can always go beyond, said Buzz Lightyear, you know what I mean? So what I want to do instead is I want to be able to figure out a specific value for this function even if it doesn't show up in the picture. I want to know, what do you get? Where would the T-chart be if I gave you x equals 17? What that tells me to do then, if I'm telling you that x is 17, that means I want you to take the x out of the equation and replace it with the 17. I believe the order of operations are strong in this classroom. You're talented. You're very skilled at simplifying expressions. You would do the problem. You would get to 39 and you would tell me that there is a point on the graph called 1739. See how close I was there? I know David McWilliams is sitting in the back row. He's like, 1738. But I went +1 on you, David. I went +1 on you. So now when I go ahead and talk about what does it mean if I say that the y value is 17? Doesn't automatically mean that the x is going to be 39. I bet you it's not going to be. I would be willing to bet 20 push-ups that the x value is not going to be 39. It doesn't work like that. It doesn't say, hey, let's just switch the letters. No, that's not okay. Because what it's telling me this time is that there's a relationship. The relationship can't change. I'm just giving you a value for the output and asking you to work backwards. You guys can't see my face in the video, but I just made a face and did like a little jig to show that I'm working backwards. This is what I really wanted to say, is that 17 equals 2 times x plus 4 minus 3, which we've been working on solving. Okay. First thing I would do would be add 3 to both sides. Boom, bam, I get 20. Sad Meg told me to divide after I do addition and subtraction. So I'm going to divide both sides by 2. That would now be 10. And since all I have left is x plus 4, I can get rid of the plus 4 by subtracting 4. It's going to tell me that the x value is 6. I have a point called 617. Now that I have completed this equation, I have additional points that I know are going to show up if I increase the number of boxes on the graph. If I gave you a graph that was the size of the gym floor, you would be able to put both of these points on there. If I had given you that, if I gave you the amount of space, if I gave you a computer, you would be able to clearly see what the relationship is. But I didn't. So we can use an equation to show it anyway. So on the other side, I'm going to ask you to do the same things, not with 17 this time. What if I tell you on the second graph that x is 9 or that y is 9? What is that going to look like? Well, it tells me to take the x out, put in a 9 instead. And I do know how to solve that. 9 minus 1 is 8. 2 times 8 is 16. 16 plus 3 is 19. And so when I do the y equals 9, remember, that's taking the y out of it and replacing it with a 9. I should still have an x. I didn't tell you to get rid of the x. I said you should still have an x this time because we are solving for it. Subtract 3 on your first step. Divide by 2 after that. If you wanted to, you could have distributed. We talked about that yesterday. We said if you want to distribute, you absolutely may. Just sometimes it's not advantageous for us if you're going to deal with fractions. So I'm just going to stick to Sad Meg right now. I've subtracted the 3. I've divided by 2. And then I just have to add the 1 after that. It tells me that my x value is 4. So there are 2 points on this graph that I can't show because I don't have enough boxes for it. Those points are 919 and 49. So here we go. Got about 5 minutes left in my video, but I have a couple more examples down here below. That means we're going to pick up the pace a little bit. You see what we're going to be trying to do. First thing I want you to do is I scroll and get myself together. I want you to create a T-chart for both of these graphs. I'm going to go ahead and start catching up to you now. The X and the Y columns are already made for me now. I'm going to use a 0 to start with. Why am I using 0? Lily Sumner said I would use a 0 because there's no parentheses. This is y equals mx plus b. It tells me that I have a y-intercept of -5, and I don't have to worry about traveling on the x-axis at all. It does give me a slope of up to and over 3. And I'm going to use that slope one more time. Up 2 more and over 3. Boom, bam. Here we go. I could connect the dots. That gives me a line. I want to know, what do you get if you plug in a +1 for x? And where would the graph be if y was equal to 7? So my man Drake Rogers in the back of the room decided that he was going to look back at the examples that we already did, try to figure out what I mean by x is 1 and y is 7, and what I'm actually supposed to do from here moving forward. Means that I want you to take the x out and put the 1 in. Oh, but Mr. Somerville, I get fractions. Oh my gosh. I don't know how to deal with that. Yes, you do. Yes, you do. You make it 2/3 minus 5. And you're smart. You remember that if you're going to subtract fractions, you have to have a common denominator. 2/3 minus 15/3. You get a fraction. So, I have absolute confidence that you know how to deal with a fraction. And if you don't know how to deal with the fraction, that's something that we'll talk about next week, just to remind you anyway. So the second question said that y equals 7. Well, how do I deal with y equals 7? Well, I take the y out. I need to figure out what x is going to be. This equation would say 7 equals 2 over 3x minus 5. Sad Meg. We're going to sad Meg this problem out. You're going to add the 5 to both sides. Then to get rid of the fraction, you multiply times 3. And then you divide by 2. We're going to get a value that says that x should be 18. I know I did a whole lot of math in my head right there, but you'll get to the point where you feel comfortable doing the same thing as well. So for the next 3 problems, what I want you to do is I want you to create the t-chart. I want you to graph it. And I want you to figure out what you get for x is 0 and y is 0. Now, I don't have enough time and the ability to do all of these problems in this 15-minute video. But I'm telling you again, I want you to tell me what happens if both x is 0 and what happens if y is 0 for each one of these. I've got about 1 minute left, so I'm going to work super duper fast, and that's absolutely okay. If you can't keep up, you can replay this video as many times you want to. That's the glory and the joy of the internet. Gotta love the interweb. Boom, there's the first one. The second one, it says that 0 equals 1/2 of x plus 1. I multiply times 2 to get rid of it. Anything times 0 is 0. When I divide by the -1, anything times 0 is still 0. My answer is that x equals -1. That's what actually showed up as the first point on your t-chart in the first place. Those last 2 boxes, the answers for those last 2 boxes will be on Blackboard, but I am officially out of time. What I want you to do for homework right now is you need to work on the equations sheet that Mr. Shelton is about to give you. And if you do not have the ability to finish that during class, it now becomes your homework. Have a great weekend. Peace.